All right, so virtual kids, or anybody that is absent for today's activity, I'm just going to ask you to make some really simple flashcards at home on a piece of paper. And I'm just going to ask you guys just to draw a really simple periodic table like I have on the board right there, okay? So you guys are going to need 16 little pieces of paper. Again, these are just regular pieces of paper. Okay, you need 16 pieces of paper, and then on the front of each of those, just give me a really simple squiggly box that looks like a periodic table right there, okay? We're not going to be super exact about how we color, but there are a couple of things we do want to be careful about, and I'll point those out when we do the coloring. So I would encourage everybody to have at least one color today, whether it's a highlighter or even your pencil. You shade it in gray, I guess. But again, the more colors you do, the more interesting. Be creative, have fun with it. But we do want to make ourselves some flashcards for the quiz on Friday, talking about the parts of the periodic table. There are quite a few little parts. So let's go ahead and grab one. We're going to start right away. I'm going to be honest, this is your activity for today. It's probably going to take us 40-45 minutes to get this done. Okay? Anything we don't finish in class, you have to PowerPoint, you can finish it up yourself. Okay? Now, I see some markers right here. Be careful using anything that will bleed through, because this is just a regular piece of paper on it. Are you guys good? You guys just gonna give me 16 pieces of paper and just make a little periodic table on it? This handout, it is on Canvas. If you have a printer, you can print them. If you want to make your own and just cut them out. But if you don't have a printer, you can just get a piece of paper and draw a really simple box on there. Try to make it look something like the periodic table though, okay? All right, so the very first part of the periodic table we're going to focus on is the metals. So metals are the first part of the periodic table. So on this part, I'm going to ask you to color in all of these. All of these that are yellow. Again, you don't have to be super exact about it, okay? Pen or pencil? Pen or pencil? Okay, all right. Again, you don't have to be super exact about it, but there are a couple of things you want to watch out for. Hydrogen at the top is not a metal. Okay, it's missing, it's right there. It's not a metal. You have this little staircase looking thing going on over here. That is kind of important. We're going to talk about that for the next step. But really quickly, right off the bat, looking at the periodic table, you should see that the metals are on the left-hand side. And there are a lot of them. I think today, the periodic table is a little bit blank, but today I think there are approximately 98, I think it's 102 metals. There's a lot of metal elements. So, metals, so again, don't write anything on the front, just color on the front. On the back, we're going to write silver metals on the back. Okay? Again, we don't want to spend an hour coloring, just try to do the best you can. Don't do hydrogen, make a little staircase looking thing over here. You don't have to label the boxes. Okay, you don't have to label it. You're just going to put a little staircase on there. The bottom two rows all do get colored in for metal. Again, you guys at home, if you're drawing it by hand, you don't have to be exact. There's a little staircase looking thing over there on the right that you want to kind of keep an eye on. Okay. All right, so on the back, you want to write down some information. These are metals. Okay. And you probably already know a lot about metals. They're pretty common sense. But metals are good conductors of heat and electric current. Metals want the electrons to move. They want electrons to leave. They want electrons to go places. And that's really important to know about metals. When we start talking about reactions, they want the electron to leave. That's why they react the way they do. Okay? I'm going to walk around a little bit because I'm blocking the screen a little bit too much. If you guys have questions, you put them in the chat box, and I'll help you guys out. Can't need to lose some weight. He's blocking the screen. All right, so there are conductors of heat and electric current. Again, the majority of elements, about 80% of them. I would say that percentage probably has to be a little bit low, probably more like 90%. But most of the elements are metals. They have a high luster shininess to it. They are ductile. Ductile means that they can be made into a wire. So you think about copper being a wire. There's lots of metals that can be turned into a wire. They are malleable, which means they can be shaped, they can be hammered in different ways. Okay? They can have a square piece of metal, you can have a flat piece of metal. You have a circular piece of metal. You're able to shape the metal really easy. And most importantly for us in chemistry, they will become a positive ion. An ion when it loses or gains electrons. So if it is a positive ion, it is going to become, it's going to lose the electron. So on the back, metal, conductive of heat, both of them. Positive ion. And you don't have to write down every single thing I have up here. You can shorten it, you can abbreviate it. Just make sure you have the information for yourself. And then I encourage you to kind of quiz yourself a little bit as you do these. All right. I am going to go kind of quick because you have this already. It's on your assignment for today. You have the PowerPoint. You have these cards, you want to print more. You guys have all this information. So I am going to go kind of quick with this. Okay? So those are the metals. And yeah, we have a lot of metals on a periodic table. Okay? And most of them are the ones you already know. Iron, nickel, copper, gold, silver, platinum. Okay? Really obvious elements that are metals that you know of. There might be something you didn't know was a metal. For example, sodium. People know sodium. It's in salt. You gotta watch the sodium intake. It's a metal as an elemental form. In the compound, in a compound form, it's not that big of a deal. It doesn't take on the characteristics of metal anymore. But sodium is a metal. All right, so I'm gonna go kind of quick. The second one. My shoe is squeaky. It's annoying. All right, so the second card are transitional metals. Now, on the periodic table, that is that lower block right there. Those are called transitional metals, just that part of the metal. And they are special metals. Okay? So, color that part in real quick, and you got some notes you can do on the back. Again, we don't have to be super exact about the coloring. Again, don't put any words on the front. Put transition metals on the back. And that way you quiz yourself. You look at it and you're like, oh, those are transition metals. You know, quiz yourself on them. All right, they are called transitional metals because they have a different number of valence electrons. Valence electrons are electrons on the outer shell, the outer ring that we were drawing on Wednesday. Okay, they have a different number. They can change the number of valence electrons. Okay, if you remember your patterns, 1, 2, skip a few, 3, 4, 5, 6, 7, 8. These are the skip a few because they don't follow the rules for valence electrons. We'll talk more about why later, if we get to that slide. Okay. They normally have between 2 and 3 valence electrons, because they're part of the skip a few. 1, 2, skip a few, 3. Normally have between 2 and 3 valence electrons, but they can have more than that, or even less than that. Okay. Even the same element, sometimes it has 2 valence electrons, sometimes it has 3 valence electrons. It is transitional. It is changing. It can change. Okay, and that does impact the chemistry. It does impact the reaction. It's having different number of valence electrons. Again, Positive ion, it's a metal. Good conductor, heat and electricity, because it's a metal. They're malleable ductile, it's a metal. Again, you don't have to write all that stuff down, because they're metals. They have the same properties as the force. Okay? Now, these metals tend to be much harder and more durable. They last longer than the metals that are way over here on the left, and group 1 and group 2. Group 1 and group 2 tend to be very soft metals. They can even crumble in your hand, that's how soft they are. Okay? I wouldn't touch them because they're very reactive as well. Many of the transitional metals occur in nature because they're durable, because they last. Many of them do occur in nature, but most of them will make what's called an ore. An ore is a mixture. Okay? There are very few elements, very few metals where you'll just pick them off the ground and there it is. Gold is one of them. That is the reason why gold is a currency, why gold is valuable to culture, because you can just find it laying on the ground. And you can make an earring, you can make jewelry, you can make a box, you can make a coin. It's just sitting there on the ground. It's hard to find today because people have been looking for gold forever. But back in the day, you just walk through the creeks and the rivers, you'd pick up gold out of the rivers and creeks. That's how common it was. And again, they're kind of doing that in Alaska still today, South America. So you're kind of picking it off the ground still today. But it's hard to find gold. Most other things, but yeah, basically, yep. Most of the other atoms or elements are going to be a mixture, though. You don't just find silver on the ground. You don't just find iron laying in the ground. It's a mixture. We can do some stuff to get silver. We can do some stuff to get iron. But most of them are going to be mixed. All right, again, you don't need to write down everything because, again, it's a metal. Okay? I'll write down things that are different. All right, slide number 3. All right, the non-metals. The non-metals, again, they are the gray ones. They make a staircase over here. You do not have to be exact about it, but do try to make a staircase. The gray make the staircase on the right-hand side, and it's hydrogen, the top left, way over there on the left. That hydrogen is a non-metal. Okay? Even though it is left, it is not a metal, it is a non-metal. Hydrogen is a non-metal. Okay? Go to the gray one. Again, you don't have to be exact about it. You don't have to color the exact number of boxes. Just make a little staircase thing over there to the right, and point out hydrogen way over there to the top left. All right, non-metals. They are good insulators, not conductors. They're good insulators of heat and electricity. So they absorb heat. They absorb the electricity. Electricity is running through this wire right now. I don't know if you guys can see me or not anymore. Electricity is running through this wire, but it has rubber on the outside. That rubber is an insulator of electricity. It is absorbing it so it doesn't go into my hand right now. If that rubber was not there, there's a nick in it, and I go to touch it, there's a wire, oh, you're going to feel it. Okay, if you got that one. Just the gray one. We're going to do these very soon. Those are in between. They're semi-metal. So just the gray one. There's not very many. There's only about 10. All right. Most are gases at room temperature. The gases are blue on this picture. The gases are blue. Some of them are liquid. Bromine is a liquid at room temperature. On there. Sulfur and phosphorus, carbon are all solids, so they are black on there, on that picture. Iodine is a solid at room temperature, but it turns into a liquid and a gas at very low temperatures, pretty much in your hand. Iodine turns into a liquid. Most of these will create negative ions, because again, they're absorbing the heat, they're absorbing energy, they're absorbing electrons. So they will create negative ions, most of them, not all. The noble gases, which we'll talk about, they're going to be their own little colors. The noble gases have a filled shell. They do not lose or gain electrons. They are non-reactive because they have all the electrons in their shell. They don't need any more. They basically do nothing, noble gases. So if you have a balloon full of helium, you can breathe the helium in and it's not going to kill you because it's not going to react with you. However, if you do the helium balloon trick, you got to remember to breathe in oxygen every now and then too. Your body needs oxygen. You can suffocate from helium. If you just keep sucking down helium and no oxygen, yeah, you'll go unconscious in about 10 to 30 seconds. Okay, so you do the balloon trick, you got to breathe oxygen too, okay? So don't just suck down helium for a very long time. The easiest way to do that is just to tilt your head up, let the helium escape out of your mouth. Again, just a special note, make sure you don't forget about hydrogen over there. Other people are trying to do something here. If you guys can't hear me or whatever, just write some stuff down on comment boxes and stuff too. I'm trying to yell. I'm trying to talk as loud as I can. All right, the next one. You're going to take a picture of your flashcards. All right, the next one is the orange one on that staircase. So again, you do not have to be exact about it. You don't have to count which box it is. But know that the orange case, the orange one, or little staircase that go right between the metal and the non-metal, and they are called semi-metals. They're kind of like metal, they're kind of like non-metal. All right? All right, this one has a little bit of information to put on there. Most important thing now to remember is that they are kind of like metals, kind of like non-metals. Right? So they are going to have properties of both being conductors and insulators of heat. They can sometimes pick up electricity, sometimes they don't. Okay? Most of them are going to create a positive ion like metal, but not all of them. So again, this is a really weird group of atoms along the periodic table. The periodic table is organized. And so this is where the organization kind of gets a little messed up. It's right at that, metal to non-metal group. You get some really weird stuff in that area. For the most part, they don't go crazy. They're not super reactive, but there are some in there you gotta watch out for, especially arsenic. So they have properties of both metals and non-metals. Most will create positive ions, some will create negative ions. Again, if it's negative, that means it has extra electrons. It gains electrons. If it's positive, it means it lost electrons, so it's more positive. These tend to be brittle. They tend to fall apart really easily. And they also tend to be lustrous, which means they have a shine to them. There's a mnemonic device to how to remember them. A little sexist, a little interpretation, but whatever. So it's called Big Strong Guys Are Smart and or big, strong guys are smart, tan, and polite. Big, strong guys are smart, tan, and polite. So it kind of helps you remember which ones are semi-metal. Got a little mnemonic device down there. But again, but they make up that staircase that separates the metals from the non-metals. Let's see what's happening. So they're not all in the same column. They're shipping, so they have different number of valence electrons. All right, take about 10 more seconds to try to get a couple last pieces of information. And again, you have all the notes on your assignment. All right, card number 5. All right. This is the first column, all the way over to the left, up and down, first column. They are called alkali metals. The very first column, remember, hydrogen is not a metal. The very first column is called alkali metals. Because they are in the first column, they have one valence electron. They are going to lose that valence electron and become a positive ion. That's what's going to cause the reactivity, them losing that electron. Okay? The ones in that first column are very reactive because it's very easy to lose that one electron to them. Okay? And we'll talk a little bit more about that, I guess, on Monday or Wednesday. Okay? They will react very easily. They are very soft. They can be cut with a butter knife. And I can even show you guys some next week to do reactivity. Yeah, they're very, very soft. I can smash them between my fingers. I don't want to touch them though because they're very reactive. They do not freely occur in nature because they're going to react. Okay? So you're not going to find these elements just sitting in the ground ready for you to pick up and play with. That would be a really bad day for us as chemists if they were just laying around. Most of them are going to literally blow up just when the air touches them. That's how reactive they are. Okay? I have a couple back there in the chemical storage closet, but not a lot. I got the ones that don't go too green. I eventually have to get rid of them because they're unsafe. When it gets warmer outside, we'll take them out to the lake and let them blow up in the lake. Pretty good one. All right, I'm going to try to pick up the pace just a little bit here. All right, the second column. The second column are called alkaline, with an Ne, alkaline earth metals. Because they are in the second column, they have two valence electrons. Again, because they're metals, they're going to create positive ion, they're going to lose their electrons. They are still pretty reactive, but not as reactive as group number 1. Most of these are shiny. Most of them are silver, gray in color. These are going to be a little bit harder, a little bit more durable than the first column. And again, these are also, because they're metals, very strong conductors of electricity. You see a lot of this is repeating. because they're metal. Metal, 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 metal. Positive ion, good conductive electricity, tiny, valuable, ductile. Okay, that's what metal would do. The main difference between this is obviously the name, and that it has 2 valence electrons. So it's not going to be as reactive because it's a little bit harder to lose 2 electrons than it is to lose 1. So if you're a parent and you're shopping through Kroger, you got 2 little kids, it's really easy for one little kid to run away and lose them for a second. It's a little bit harder to lose both your kids. You figure it out before, after a while, right? So the electrons are the same way. It's really easy to lose 1. Losing 2 or 3 or 4, it's harder to do on that. So it's a little bit less reactive, but they are still pretty reactive. All right, so again, I'm going to kind of go a little bit quicker here. All right, go over to the right hand side with non-metals. Now, this is the 3rd column from the right. And that's important. That is important. The 3rd column from the right. If you're drawing it by hand, you might want to make a special point that is the 3rd column from the right. These are called chalcogens. They are non-metals. It's also known as the oxygen group. That's the